Hey guys, welcome to your second video lesson from chapter 13. Hopefully in the first video, 13.1, you talked a little bit about sine, cosine, tangent, some of the basic trig functions, and you should also have watched your first video on the unit circle. So if you haven't watched that first unit circle video, I encourage you to do so because that'll make a lot of this make a lot more sense. But let's go ahead and start talking about some of the things in 13.2. First of all, it talks a little bit about the initial side and the terminal side. And during that video of the first unit circle, we talked a little bit about this idea that, look, if you start with a circle with some radius r, now we've been doing the unit circle, so the radius has been 1, but if I start with a circle with a radius of r, and I swing an arc, all right, this first side here, we call that the initial side, and then where the angle ends, we call that the terminal side. All right? So this would be the terminal, and this would be the initial. Now, if the initial side is right on the x-axis like I have it drawn here, that is said to be in standard position. So basically, the initial side is on the x-axis. All right? Now, two angles that are coterminal, again, coterminal says that they have the same terminal side. All right? So, for example, if I had an angle where maybe I rotated to 90 degrees, an angle coterminal with that would be to go another full rotation around, and that's so that basically that would be ending in the same spot. So basically, another way to say coterminal is two angles that end in the same place. And you'll understand more of this. I'm going through this fairly quickly just to get the definitions out to you, and then we'll go through and define more of these as we work through this lesson, okay? All right, radian measure, as we said before, is another way to measure an angle. We know that pi radians is equivalent to 180 degrees. All right, and so when we talk about radians, it's just another way to measure an angle. No different than we can measure distance in feet, inches, miles, centimeters, etc. All of those are just ways that you can make measurements. Radians is just another way to measure an angle. All right? Now, the last couple of things that we have to talk about is this idea of a sector. A sector of a circle is basically a piece of pie. All right? So this would be a sector, and when we're talking about area, we're talking about the area of a, I'll just say a piece of pie. All right? Now, that would be a sector. Eventually, we're going to talk about this idea of an arc length, and an arc length would be the length along the arc from basically the outside of that sector. And again, we'll define that more. We'll define that a little bit better in just a few minutes here. All right. Finally, a central angle is basically an angle made by two radii. All right. So this radius here and this radius here form a central angle with that. And so we're going to be using that quite a little bit over this lesson. Okay? All right, so let's start with angles in standard position. First of all, an angle in standard position, in a coordinate plane, an angle can be formed by fixing one ray, and that first ray, we call that the initial side. Okay, so the initial side, and rotating the other ray in a counterclockwise rotation, we call that the terminal side. And we've already alluded to this a little bit in the video, in the first unit circle video, so this should not be anything new to you. We start with our initial side, and then we rotate some counterclockwise rotation about the origin, 0, 0. All right? And so we rotate around the origin, all right? And an angle in standard position is if the vertex is at 0, 0, or the origin, all right? And its initial side lies on the positive x-axis. Okay, so this angle that's drawn right here, this angle, whatever this happens to be, maybe this is a 140 degree angle, would be in standard form because its initial side is here on the positive x-axis, and its terminal side kind of kicks out over here like this, and then makes an obtuse 140 degrees. Okay, so let's draw some angles in standard position. Okay, let's go ahead and draw a 405 degree angle. Now think about 405 degrees. We know that 360 degrees is a full circle. So if I take 405 and I minus a full rotation from that, that tells me that that's the same thing as 45 degrees. All right? So basically what we're saying is start here with our initial side on the positive x-axis and go one full rotation around. Well, that's 360 degrees. And then I have to go another 45 degrees, which as you know is halfway between 0 and 90 degrees, right? So that right there would be a 405 degree angle. Because 405 is 45 degrees more than 360, the terminal side makes one whole revolution in a counterclockwise manner, plus 45 degrees more, again, counterclockwise, because this is positive. Remember, positive rotations are counterclockwise, which seems a little backwards. It seems to me that counterclockwise should be negative and clockwise should be positive. But when we name our angles, we start here at the x-axis and we go in a counterclockwise rotation. That's a positive rotation. So a negative 65-degree angle would say start here in my initial side, being in standard position, and go down 65 degrees. Now 90 degrees would be right here. Okay, 45 degrees would be like right in there, so probably right in there someplace. And I can assume that that would be a negative 65-degree angle. Okay, and again, because negative 65, because negative 65 is negative, the terminal side is 65 degrees in a clockwise rotation from the positive x-axis. And again, because it's negative, we go in the clockwise rotation. So important that you understand, positive is counterclockwise, negative is clockwise. All right, make sure you have that piece of information. So let's talk a little bit about this idea of coterminal angles. Coterminal angles are angles that basically land in the same spot. All right, so let's think about where 210 degrees is. 210 degrees is 30 degrees past 180. So starting here, if I go 180 degrees, that would be there, and another 30 degrees past that puts me at 210. So this would be a 210-degree rotation about the origin for that angle in standard position. Okay? Now, it says find one positive and one negative angle that are coterminal with 210. Well, let's think about this. What if I went another full revolution? Okay, what if I went 210 degrees and I went one full rotation around that? So let's change my pen color here. And let's go one full revolution past that. So another full revolution, which is another 360 degrees. Well, 210 plus 360 is 570 degrees, and so a coterminal angle with 210 is 570. Okay, what about the other way? What if I started with my 210 degrees, okay, I started with my 210, and now I went backwards 360. Well, going clockwise 360 is equivalent to subtracting 360, and so 210 minus 360 comes out to a negative 150-degree angle. All right? Now, eventually we'll be able to kind of look at that and say, well, let's think about that. A negative 150-degree angle is 30 degrees short of a negative 180-degree rotation, which is the same thing as 210. So again, coterminal angles are angles that land you in the exact same spot. Okay, a couple of checkpoint problems at the bottom of the page here. Let's go ahead and first of all draw the angle and then give a positive and a negative coterminal angle. All right, so 485. If I minus 360, okay, that becomes 125 degrees. Now 125 degrees, I know that's past 90, right? And that should be another 35 degrees past 90 degrees. So probably right in there someplace. It could be a pretty good approximate for that. All right, so that would be 125 degrees. All right, so to make a 485-degree angle, we would go from the origin, we'd go one full circle and another 125 degrees to get to this angle right here. So a positive coterminal angle with that would simply be 125 degrees. A negative coterminal angle would then say, all right, listen, if I have that same angle, okay, starting from this angle right here, and I want to find a negative coterminal angle with that, all I have to do is make a clockwise rotation of 360 degrees. Well, that equates to subtracting 360. Again, every time you find a coterminal, you're adding 360 or taking 360 away. I already have a positive angle that's coterminal with 485. Now I need a negative one. Okay, so if I minus 360 again, okay, this comes out to a negative 235-degree angle. So positive 125 and negative 235. What about negative 75? Well, negative 90 would be all the way down here, so negative 75 is probably going to be in there someplace. So this would be a negative 75-degree angle. All right? Now, to find another angle that's coterminal with that, I would essentially add 360 and take away 360. Right? So if I'm already at negative 75 and I take away another 360, that amounts to taking negative 75 and going another full clockwise rotation, which again is subtracting 360. Okay, so this ends up being negative 435. All right, now what if I went the other way? Okay, what if I went the other direction? What if I started at my negative 75, now I go counterclockwise, one full rotation? Well, that would be equivalent to adding 360, and negative 75 plus 360 comes out to positive 285 degrees. Okay, notice you have one negative and you have one positive, and those are both coterminal with negative 75 degrees. All right, yesterday in our last unit circle video, we talked about this idea of converting between degrees and radians. If you have nice pretty numbers that you already know on your unit circle, like for example 350 degrees happens to be right down in here someplace, okay, 315 degrees would be basically this distance right here, all right, and that amounts to, let's see, this would be 8 pi over 4, okay, so this would be 7 pi over 4. So if you have your unit circle from yesterday, you can say that this is 7 pi over 4 radians. If you don't have your unit circle from yesterday, well then maybe we ought to think about doing this instead. Okay? What I would think about doing is saying, listen, I want to multiply by something that's going to get rid of degrees and leave me in radians. So if I'm going from degrees, to radians, I would multiply by radians over degrees because I want to get rid of degrees. So I want degrees to cancel with degrees, and I want to make this as pi radians. Now, what's kind of cool about this is this ends up being 315 divided by 180 pi. I'm not going to put the pi in there, but I want to reduce that first. Now, I'm not great at reducing fractions, and so maybe I'm going to do something a little different instead. What I want to do instead this time is I want to go ahead and make this 315 divided by 180. And then I press enter, and it's 1.75, and then I just hit math, change it to a fraction, and that's 7/4. So what that tells me now is that this is 7 pi over 4. All right? What if I was going the other way? What if I was changing pi over 6 to degrees? Well, if I know from my unit circle from yesterday, pi over 6 is the same thing as 30 degrees. And I should see that on my unit circle from yesterday. If I don't, then I say, all right, well, I want to get rid of radians, so I want radians on the bottom, and I want degrees on top. So 180 degrees over pi radians. Notice that pi cancels with pi, and I end up with radians cancels with radians, and so I get 180 degrees over 6, and 180 over 6 is simply 30 degrees. All right, a couple of checkpoint problems. You guys try too, and then we'll be right back with solutions. All right, changing this from 200 degrees, we want to multiply by pi radians over 180 degrees. Okay, degrees cancels with degrees. This is 20 over 18. They're both even, so that goes in there 10 times and 9 times. Okay, so it becomes 10 pi over 9 radians. All right, and the second one, this is pi over 5. Again, this is in radians. Okay, we'll never give you a degree measure in terms of pi, just so you know. Okay, so pi over 5 radians, I want to multiply by 180 degrees over pi radians. Cool, degrees cancels with degrees, radians cancels with radians, and I get 180 degrees divided by 5, and 180 degrees divided by 5, that comes out to 36, yes. 36 degrees. Okay? Now, the last piece of this lesson is something that's kind of cool. In geometry, when you did this in geometry, we had to make a proportion, and so we had to say the proportion of angle out of whole thing equals the area of the sector out of the whole thing. Well, now that we're defining that an angle can be given in radians, again, the angle has to be measured in radians. It cannot be done in degrees to do this. The length of the arc is simply r times theta, where theta is the measure of the central angle created by the two radii. Now again, arc length is the distance. It's the distance along the circle from here to here. All right? The area of the sector is the area of that piece of pi. All right? And that's 1/2 times the radius squared times theta. All right? So let's take a look at example 4. The first thing it wants us to do is it says find the arc length and the area of a sector with a radius of 15 inches and a central angle of 60 degrees. Okay, so this is 60 degrees, and the radius is 15 inches. All right, we want to find this distance, which is the arc length, and we want to find this area of this sector, which is area there. All right, now the first thing we have to do is we have to convert 60 degrees into radians, because this formula doesn't work. S equals r theta, and A equals 1/2 are squared theta. Neither of these work unless you change your angle to radians. So first of all, 60 degrees, I want to multiply by 180 degrees on the bottom because I want degrees to cancel, and the equivalent to 180 is pi radians. Okay, so this becomes 60 over pi, which is simply pi over 3 radians. All right, and if you had your unit circle, you'd know that 60 degrees is pi over 3 radians. So then, to find the area, the arc length, we simply take the radius, which is 15, and we multiply it by the angle, which is pi over 3. This becomes 15 pi over 3, or simply 5 pi, all right, because 3 goes into 15 5 times. And then a rough approximate for that would be 15.71 inches. Okay, now this is in inches because it's a length. Remember, it's the length of that piece. So how much of that length, or how far is it along the circle from that dot to that dot? That's kind of what we're looking for. Now the area of that now says, what is the area? How much pizza am I getting? I suppose in the arc length we're talking about how much crust are you getting, and the area then says how much pizza are you getting. Okay, that becomes 1/2 times the radius squared, so that's 15 squared, times theta, which is pi over 3. Now I know this looks kind of messy, but it's just basically 1/2 times 225 times pi all over, well, times 1/3. And so this is 2 and 3, which is 6 on the bottom, 225 pi, so you can type it in your calculator that way. The bottom line is that's the right answer, that's the exact answer. This is in square inches, but to say 225 pi over 6 square inches doesn't make a heck of a lot of sense. So I'm going to go ahead and reduce that, do the multiplication in my calculator. It's 117.81 square inches. All right, remember, area should be given in square inches, length should be given in just inches. All right, one checkpoint for you guys to try in the end. Go ahead and try that last checkpoint problem. We'll be right back with a solution. Draw a picture. Start off with a circle with a radius of 5, and we have an angle of 75 degrees. So I know that 90 degrees would look roughly there, so I'm going to go about like that, just so my picture makes sense. My angle is 75 degrees, which is the same thing as pi radians over 180 degrees. Degrees cancels with degrees. Okay, and then 75 pi over 180, I would just go to my calculator and say what is 75 divided by 180, and that comes out to that decimal, which is the same thing as 5/12. All right, so this is 5 pi over 12 radians. Okay, so that's my angle converted to radians. The length of the crust, again, the length of the crust would be my arc length, and arc length is found by r times theta. My radius is 5. This is 5 pi over 12, which becomes 25 pi over 12. But that doesn't make a heck of a lot of sense. So we would actually go ahead and do what 25 pi over 12 is to get the exact answer. This is going to be in feet, and I don't have that number. I can come back with it in just a minute here. The area then becomes 1/2 of the radius squared times theta. So it's 1/2 times 5 squared times 5 pi over 12. Well, 5 squared is 25, and so this becomes 25 times 5, which is 125 pi, and 2 times 12 is 24. Now this is going to be in square feet. Now, if I want to know what those numbers are, I would simply plug them into my calculator, but these two answers are certainly sufficient for now. Okay, for now. If it says give the exact answer, then we would leave the answers like this. Okay, make sure area is in square feet, make sure length is in feet. That concludes your lesson in 13.2.